So my name is Dan Behrens. I'm a technical marketing engineer inside Cisco's IoT business unit, focused on our industrial security solutions. I've been with Cisco for close to 8 years. Prior to that, I worked for Rockwell Automation for close to 10 years in their tech support, supporting their industrial controls, networking, and applications. Now, realistically speaking, IoT can have very different meanings depending on who's using it and the context. So in the case of the business unit inside Cisco, typically what we're referring to are products that are being developed with very specific use cases or very specific environments in mind. So that might mean ruggedized equipment to go in places like parking garages or ports. That may mean specific certifications or functions that are needed by industrial environments, things like manufacturing, oil and gas, or utilities, or very specialized use cases like tracking across distributed areas. Now, obviously, I'm not going to sit here and do a read through of every single product on the screen, but just be aware that we're taking a lot of the best in breed capabilities from the rest of the Cisco portfolio and putting them in that candy coated shell, so to speak. Now, today we're going to focus on our industrial security solutions, specifically on Cisco Cybervision, which is a industrial visibility solution that can help organizations recognize what devices are deployed in those environments and what types of communications are occurring. It wouldn't be a security slide with a little bit of doom and gloom, but ultimately, a lot of the recent events that we've seen across the world have really triggered governments and organizations to start paying more attention to how they're actually securing these industrial environments. Now, the one note I will say is that many of these cases, these are more of the traditional IT type of events that just happen to be bleeding over or impacting the controls equipment. In the case of the Colonial Pipeline, for example, it was really the inability for anyone to be confident in the fact that no industrial assets had been compromised that led them requiring to shut down. Of course, also the inability to bill their customers came into play as well. But there are some unique functionalities, unique pieces when we start talking about industrial environments. In many cases, and this can be a religious or a political debate, but in many cases, organizations thought that their operations were really air-gapped or disconnected from the enterprise or from the internet at large. But new functionalities, things like predictive maintenance or quality control, is really driving the need for increased connectivity and increased data, which really realistically means being air-gapped just isn't an option anymore. Now, many of these resources are going to be deployed for 5, 10, 15, even longer years in many of these environments. And what that really means is that organizations have resources that are vulnerable. Not whether it's because they're the age of the device in the environment or just how critical that device is, and they can't patch it, they can't take it down to do so. And so as an end result, there's a lot of vulnerable devices that are deployed across the entire environment. Also in industrial environments, the legitimate commands themselves, as long as they're sent at the right time, could actually cause destruction. Right? We start talking about something like a steel smelting plant. The stop command done at the right time is exactly what the process should do. Done at the wrong time can spill a bunch of liquid steel all over the place. Right? So point being is that the commands themselves can look and feel the exact same. It's really the context of the overall process that can really impact, is this disruptive or is this just business as usual? And then obviously, everyone's talking about how things have changed the last few years, but the increased need for remote access and getting both vendors and employees access to the equipment for troubleshooting and diagnosing issues is continuing to expand over time. And what this really means is that a lot of our traditional IT solutions aren't able to be leveraged, at least by themselves, directly in these industrial environments. A good example, we start looking at tools like Cisco's Identity Services Engine, which has a very rich set of profiling capabilities, but it's going to look at details like the DHCP request information to know the vendor of the device. Well, industrial assets, because the IP address is realistically one of the key items used for control, they're typically going to be statically IP'd, so we're not going to see DHCP information. ICE can look at things like the web header information to know, is it my MacBook or my iPad or my iPhone? These devices, PLCs or programmable logic controllers, aren't going to be doing web request type of access. ICE can do something like fall back and do an Nmap scan and try and fingerprint the device based on what ports are open. In an industrial environment, if we do something like an Nmap scan, if you're lucky, you'll just cause a denial of service while you're doing it. If it's going to be a bad day, you can actually make these devices very expensive paperweights. Again, the IP stacks on a lot of these devices were developed to do what they do and nothing else, and they don't tend to handle an out of bounds kind of communication. And so it's important to recognize that there's a lot of intricacies when it comes to identifying and recognizing what assets are inside these environments. Now, for most customers, I've been having these conversations for a few years now, and it used to start off with the need to actually segment between the enterprise and the operation space in the context of an industrial DMZ. We've gotten to the point where that's somewhat accepted across the industry, and typically not a conversation that's needed. But when we're talking to organizations about the journey to deploying security in industrial environments, we usually call that step zero. If you don't already have one, that realistically is the starting block. But beyond that, the next phase is really on understanding what assets are in the environment. Again, these environments are going to grow over time. These devices are deployed in many cases for decades at a time. And so many organizations just don't have a firm understanding of what resources are out there and what normal looks like, so to speak. And so that's really the first phase, is getting a deep understanding of what assets are out there. And as I mentioned, some of the limitations on discovery capabilities really start to come into play there. But once we have that information, that's when we start moving into more of a segmentation approach. And then later on, getting into more of an advanced kind of integrated IT and operations, secure operations center, for example. And so some of the solutions that really come into play when we're talking about this, first of all, Cisco Cybervision. Like I mentioned, we're going to dive a little bit deeper into that here in a moment. But realistically, it's an OT, or an operational inventory tool that gives the ability to understand what's occurring at the process level. So not only what assets are deployed and what devices are communicating to each other, but what's being said within the industrial protocols themselves, or within the process information itself, so we can recognize exactly what types of control and applications are occurring. Cisco also has the Cisco Firepower solution, and we've taken that, as I mentioned, put it in a candy-coated shell with our industrial security appliance, or ISA 3000, and that allows us to take that information and start deploying those segmentation policies. And then earlier today, Ben did a great job deep diving into Cisco SecureX, and we'll talk a little bit through how integrations allow us to start bringing that functionality into the operational space as well. Now, Cisco Cybervision itself is a two-tier architecture. So there's the Cybervision Center. This is where users interface with the tool. This is where integrations are going to occur. As a fully RESTful API, so this is where we can do custom reporting or integration into third-party solutions as well. Realistically speaking, it's the primary window or primary interface to the tool from a user perspective. The other component, though, is the Cybervision Sensor. And the sensor is what's actually performing deep packet inspection. It actually understands or decodes industrial protocols, and it uses that functionality to pull out all the asset information and communication information that's occurring at that process level. Now, the sensor is sending its information back up to the center in the format we often refer to as application flow, but essentially it's a lightweight metadata. And the point here is that we're not having to send all of the traffic back to some centralized location. We're actually performing that analysis right there directly on the end device or on the network devices themselves. And so it can actually be deployed on our industrial Ethernet switches, as well as our industrial routing portfolio, as well as on the more traditional enterprise Catalyst 9300 and 8400s. But again, the point here being that I essentially have the ability to perform that deep packet inspection on the traffic right at the switch where these devices are connecting to allow me to get that full visibility and full understanding of what's occurring at the process level. Now, some of the ways we're doing this, our industrial switches as well as our enterprise switches have a functionality you may hear it referred to as IOX, or application hosting. Essentially these are multi-core processor devices that have some of their resources completely dedicated for the actual networking functionality itself. So for the switching functionality in the case of the switch on the screen, as well as additional resources or additional cores that are there and able to be leveraged by applications that organizations can deploy on their own, or applications that Cisco develops, like the Cybervision sensor that I just talked through. Now, the big piece here is that the sensor itself, when it's running in that application or application hosting or IOX framework, is essentially connected to the switch through a virtual backplane, so to speak, or a virtual interface. And so what that means is that while it's running on the same hardware, which means I don't need additional cabling or additional hardware to get at the traffic, it's non-impactful to the switch itself, right? It's actually not in the control plane, so to speak. And so should there be a situation where possibly the sensor has some form of an issue, we don't have to have concerns of that impacting the switch being a switch ultimately at the end of the day. And so what that really means is we start looking at some of the resources or resource limitations or restrictions that are available on the platform. The idea being is we can actually restrict specific resources for specific functions. So the memory and CPU functionality that's required for the control plane or for the network devices themselves, again, is not impacted by the actual applications that are running inside the framework on top of that device. So with all that being said, why does this really matter? Realistically speaking, when we're looking at industrial assets, most of their communications are more traditionally of an east-west type of nature, right? It's a programmable logic controller talking to an I/O device, or it's a human-machine interface, or HMI, pulling information from the PLC. And so the point being is, in many cases, that traffic doesn't leave the access switch or the edge switch, if you will, where those end devices themselves are connected. And so historically, customers were left with a decision, right? Do I either go at the aggregation, which is going to require less cabling and less hardware, but means I'm not going to get full visibility over everything that's being communicated? Or do I do something like distribute a bunch of sensors or a bunch of hardware across the environment so I can get full visibility into all the access communication that's occurring? So the beauty, if you will, of Cybervision and the ability for that sensor to run directly on the network switch itself is that I don't have to compromise, right? I can have full visibility of all the traffic that's going across that access switch without the need for me to stand up additional cabling or additional hardware to actually support all of that traffic. When we start looking at controls and kind of what the industry is doing today, it's all about going faster, right? How can I tune the process to run as fast as possible? And realistically speaking, that leaves organizations concerned of the impact of spanning traffic or even remote spanning traffic across the environment. What is the impact of doubling or tripling that traffic? And so because that sensor can do that analysis right there locally where the traffic is, I don't have to have concerns over impacting the actual or adding jitter and delay to the actual controls traffic itself, which can ultimately impact the end devices themselves. The other piece, so Cybervision is primarily a passive solution, meaning we're looking at that traffic as it's going across the network and pulling out the information that's relevant. But we do also have an active functionality, but our active capability is actually informed by the passive. And what I mean by that is, say, for example, it's a Rockwell environment and they're running Ethernet IP or Common Industrial Protocol as the industrial protocol that's being communicated. The sensor itself can passively see there's a device and it's talking Ethernet IP, but I don't know details about it. And the center can tell the sensor to go ahead and perform a discovery using Ethernet IP. So we're not scanning a bunch of different protocols or testing and trying to figure out what the device is. We're using the intelligence of the fact that we're already seeing the communications as they're occurring to inform our ability to use that active functionality. And because it's on the sensor itself, which means it can be distributed across the entire environment, that ultimately means that I don't have issues with going through a natted boundary or going through a firewall or requiring an organization to deploy a bunch of rules to make their firewall Swiss cheese, so to speak. So it allows us to get that full visibility across the entire environment without having those types of implications.
Can I jump in with a question here for you?
Yeah, absolutely.
You had a slide earlier that talked about this being cloud-centric. Do you have solutions for on-premises for networks that need to be totally air-gapped? I'm thinking power utilities in North America specifically that have to follow NERC CIP compliance and can't, you're not allowed to plug it into a DMZ that, attaches to the internet.
Yeah, absolutely. So I apologize if there was any confusion on an earlier slide. Cybervision is an on-prem solution on its own, right? So the Cybervision Center is either deployed as a hardware-based appliance based on Cisco's server technology, or as a virtual appliance. We do support today VMware as well as Hyper-V. We do also have an AWS image available up in the Amazon Marketplace. But in general, Cybervision is developed as an on-prem solution and can run fully offline without any type of internet connectivity.
Awesome, thank you.
Yeah, thank you. So we'll dive into a demo here in two more slides, but some of the information that we're gathering, again, details about the assets themselves. If there are vulnerabilities that have been associated to that device, we can actually highlight those for organizations and quickly pinpoint where those are inside the environment. And then using those details, type of device, the communications the device is performing, we can calculate a basic risk based risk by likelihood, or I'm sorry, a risk score based on the likelihood and the overall impact of that device. And so again, the point being really to help organizations answer the age-old question of where do I get started once we start learning this information. Now, in many cases, Cybervision can be leveraged by different users inside the organization. Operations might use it as more of a troubleshooting tool. But when we're typically talking more of a SecOps or an IT security focused group, realistically speaking, they're not going to log into Cybervision on a daily basis, right? So the point there is that Cybervision has the ability to export all of its information to tools like a SIM tool like IBM QRadar or Splunk. And those types of alerts can then trigger someone to go into Cybervision to dive deeper into exactly what's going on. But through that capability and through that information, we have the ability for users directly inside Cybervision to escalate or promote the events inside Cybervision into Cisco SecureX threat response. And so we'll show that here in the demo. But the point being is it allows us to take all this rich industrial context that we're learning and share it with other tools, in this case, the Cisco SecureX threat response, to take action or get more context and details from across my enterprise security deployment. And for the sake of time, I've already gone ahead and logged into the Cybervision Center, and I've already gone ahead and pulled up one of our primary screens here. But essentially what we're looking at is a map view of the assets that we've discovered inside the environment. So a couple pieces. I do have the ability to logically organize the data based on a grouping mechanism. In this case, I've created a very simple paint and cell 1, cell 2, and cell 3 within the paint location. But essentially allows me to help organize exactly how the data is going to be displayed inside the system. Here, for example, if we go ahead and pick on this device and go into some of the details, we can see that, again, because we actually understand or we're decoding those protocols, we can actually get information as far as what this device is and the relative details about it. So in this case, we can see the firmware version, the make and model, so to speak, even the name of the program that's running inside of it, in this case, because it is a PLC. But essentially allows me to have all that rich information about this resource. And again, we discovered this passively, so non-impactful to the device itself, and also without requiring additional hardware or additional cabling to get at all those details. The other piece, though, is as we are gathering information about this device, we're even getting to the level, for example, of what variables are being communicated. So in this case, we can see that there are 2 variables being communicated between these 2 PLCs. So these are the actual data points, if you will, that are being exchanged between these devices. So like I mentioned, not only understanding who's talking to who and what's being said, but more importantly, the details of the process itself and the information that's being exchanged. The other piece is, once I've had that chance to essentially learn all the information about those resources and what communications are occurring between those devices, I then have the ability to create a baseline. And a baseline is just that, right? It's my way of essentially saying this is what normal looks like. So in this case, I've created this production 1 baseline. We can dive in and see that there are, in fact, 8 different alerts. If you come over here, I'm actually just going to go to these changed activities, and we're going to look at this one here. When we go into the details, what we can see is that at the time I created the baseline, only one of those variables was being communicated. Since then, though, a new variable has started to be exchanged between these resources. So again, it allows me to quickly recognize what's changing at the process level. One point to call out here, though, is it's only through doing that deep packet inspection and understanding the protocols that I can really pinpoint this level of detail. This sync new variable that's being communicated is a Boolean, right? So if I was just looking at the volume of traffic between these devices, I'd have it to tune it down to a single bit. Which obviously would mean a bunch of false positives and a bunch of issues trying to actually detect that in the environment. So the point being is that understanding this information is realistically what allows us to get to that level of detail without creating a great deal of false positives, so to speak. But the last piece is, as we're observing the environment and we're seeing these devices communicate, we're also obviously going to be generating events for when issues occur, when new devices come online, any type of activity that's occurring in the environment. And so here, for example, we can see there were 3 different control system events today. And I go ahead and pick on this one here in the middle. We can see that there actually was a stop command that was sent from one of the workstations inside the environment. Now, obviously, I have the ability right from here to dive into the details as far as what does Cybervision know about these devices themselves and this communication that's occurring between them. But here you'll notice this report to SecureX button. Again, what this realistically does is allows me to promote this event, if you will, to an incident inside Cisco SecureX threat response. Now, for the sake of time, I've already done that beforehand. But here we can see that here's the actual event itself. In this case, it's the stop CPU command. We can see what are the details as far as what resources were involved in that communication. We can dive into all the details that were being sent from Cybervision. So in this case, the fact that it's a Rockwell controller, the make and model, all the same details that were sent earlier. But the benefit here is I now have the ability to not only get this information as far as what does Cybervision know about these devices, but also what is the rest of my security deployment across my environment. So right from here, I have the ability to choose this device and perform an investigation. If I have any type of orchestration put into place, like Ben was talking about earlier, I have the ability right from here to run my different playbooks, so to speak, or dive deeper into those details. Again, for the sake of time, I've already gone ahead and opened up an investigation. And so here we can see, what are other solutions that are deployed across the environment learning about this specific device. So in this case, we can see the Cisco Secure Endpoints or the Advanced Malware Protection AMP solution has discovered details as far as some of the files that were being transferred on this device and some of the connections that were occurring with other devices inside the environment. And so, again, the main point here being that Cisco Cybervision allows me that ability to get that deep understanding of everything that's occurring at an industrial level. But now I can take those details and share it with the rest of my security deployment across my enterprise to get more information as far as what am I seeing about this device across my entire deployment.
So is it the fingerprinting data that you are getting from the console itself, or you can actually see the data of the file that is transferred?
So that specific one, it was the file hash. So it was a hashing being done by the Advanced Malware Protection solution.
I'm so glad you covered that it was actually looking at the payload of the protocol. I remember you said you establish a baseline. I'm wondering how that baseline is established. If you could talk about that a little bit.
Sure. Yeah. So in the case of Cybervision, it is a user action, right? So I essentially go in and I create my baseline. Now I can create more than one, right? So I could say this is a production baseline versus a maintenance baseline, or I could say, if you're a scenario where you have different equipment online based on what's being produced, you can have different baselines for those scenarios, but they are user generated. So as a user, I essentially say, this is normal. Tell me if it changes.
Do you have the ability to have Cybervision either directly itself or through some sort of hook to I'm going to call it the industrial version of Firepower, right? The ISA, to actually stop that communication? So if you had something that deviated from baseline, will it actually take action? Or is it purely make you aware that something is about to go badly and then you need to go manually intervene through the PLC system or some other one?
Yeah, so Cybervision on its own is pure visibility, but you hit the nail on the head, right? We do have direct integrations with tools like the Identity Services Engine, as well as with tools like Cisco Firepower Management Center to share all those details. And so one of the use cases we do have is the ability for a deviation from that baseline to be stopped. Now, with that being said, in industrial environments, most organizations want a user to get eyes on it before they take any type of action. So most customers take the approach of I'll investigate it first. But if it is a customer that wants that automation and orchestration, we do have those capabilities.
Cool, thanks.
It sounds like Cybervision has a great advantage that most PLC traffic is unencrypted. To get that level of visibility, is there any limitations if that stray system that does implement encryption, the one PLC in the world, does that have bring some limitations to the capabilities of the tool?
Yeah, so today Cybervision is focusing on decoding the protocols, and that's pretty difficult to do when it's encrypted, right? So yeah, in those scenarios, we can obviously see the header information and the connection, but we wouldn't be going all the way into the process level details. As we continue to see advancements in this space, and encryption being one of those, we continue to kind of weigh our options as far as bringing that functionality in. To be honest, you made the joke about the one. There's vendors out there that have products, but there's not really a vendor out there yet that has like the full suite of products supporting encryption. So encryption in these spaces is pretty limited today. But frankly, that's where other solutions like Cisco's encrypted threat analytics could be leveraged as well.
Thanks.
When a vendor releases a new PLC or has an enhancement to their product and they develop a new protocol, it's going to be proprietary, assuming they're not following any open standard. How will SecureVision see that?
Yep. So kind of two pieces there. So the easier part of that is what we're finding is most vendors are actually aligning to open. I wouldn't say open, but standards. Frankly, it helps them out in terms of being able to support different deployments. But with that being said, if it's a protocol we don't support, whether it's proprietary or not, it does require our engineering team to essentially either work with the vendor, and we've done that in many cases, or more of a reverse engineering type of approach. And so typically we just work with customers on gathering information as far as packet captures and details like that. And then our engineering has the ability to create I'll call it the protocol parsers, so to speak, based on those details.